Interquartile range. The interquartile range is the difference between the upper quartile and the lower quartile. So, Q3 minus Q1. In one of my previous statistics videos, I covered about quartiles, how to find the quartiles in discrete data and grouped and ungrouped frequency tables. So, if you want, check it out for more detail. Now, moving on to an example, a frequency distribution is shown here. So, let's use interpolation to find an estimate for the interquartile range. Now, the data is represented here in a grouped frequency table. So first, let's find the value of the upper quartile. Now, all the frequencies here add up to 50. So, Q3 equals 3 over 4 times 50 equals 37.5. So, this is the 37.5th data value. And the 37.5th data value falls into this class interval. Here, the data has gaps and hence the class boundaries for this class interval are 60.5 and 80.5 and the frequencies of the previous classes add up to 30 and with this class the total add up to 42. Now let's use interpolation to find the value of the upper quartile. So here are the class boundaries and the cumulative frequencies. So Q3 minus 60.5 over 80.5 minus 60.5 equals 37.5 minus 30 over 42 minus 30. Q3 minus 60.5 over 20 equals 0.625. Solving this equation gives us Q3 equals 73. So now this is the upper quartile. Moving on to the lower quartile, Q1 equals 1 over 4 times 50 equals 12.5. The lower quartile is a 12.5th data value and the 12.5th data value lies in this class interval. The class boundaries are 20.5 and 40.5 and the cumulative frequencies for the previous classes and this class are 5 and 50. So now to find the lower quartile, let's use interpolation. So, Q1 minus 20.5 over 40.5 minus 20.5 equals 12.5 minus 5 over 15 minus 5. Q1 minus 20.5 over 20 equals 0.75. Q1 equals 35.5. Now, this is the lower quartile, so the interquartile range is Q3 minus Q1, then 73 minus 35.5 equals 37.5. Range. The range is the difference between the largest and the smallest values in the dataset. Now, if we take this example, the table here shows the monthly income for workers in a factory. So here, the largest possible value is 1,300 and the smallest possible value is 900. So, the range is 1,300 minus 900 equals $400. A measure of spread is a measure of how spread out data are. The range and the interquartile range are two measures of spread. Measures of spread are sometimes called measures of dispersion or measures of variation. Interpercentile range. The interpercentile range is the difference between the values for two given percentiles. For example, the data represented here are also in a grouped frequency table. Now, use interpolation to find an estimate for the 10% to 90% interpercentile range. So, the 10th to 90th interpercentile range is the difference between the 10th and the 90th percentiles. So, in my previous statistics video, I covered about how to find the percentiles in grouped frequency table. If you want, check it out for more detail. Now, moving on to the example. First, let's find the 10th percentile. The total of the frequencies add up to 30. So, the 10th percentile is P10 equals 30 times 10 over 100 equals 3. So, the 10th percentile is the third data value and the third data value falls into this class interval. The data here has no gaps. So, the class boundaries for this class interval are 25 and 27. Now, using interpolation to find the 10th percentile, here the class boundaries are 25 and 27 and the cumulative frequencies are 0 and 12. So, P10 minus 25 over 27 minus 25 equals 3 minus 0 over 12 minus 0. P10 minus 25 over 2 equals 1 over 4. Solving this equation gives us P10 equals 25.5 degrees Celsius. So, now this is our 10th percentile. Now, let's find the 90th percentile. So, P90 equals 30 times 90 over 100 equals 27. This is the 27th data value and the 27th data value falls into this class interval. So, the class boundaries are 29 and 31 and the cumulative frequencies for the previous class intervals and this class are 26 and 30. So, here are the class boundaries and the cumulative frequencies. So, P90 minus 29 over 31 minus 29 equals 27 minus 26 over 30 minus 26. P90 minus 29 over 2 equals 1 over 4. P90 equals 29.5 degrees Celsius. And hence the 10th to 90th interpercentile range is P90 minus P10 equals 29.5 minus 25.5 equals 4 degrees Celsius.